Hi, everybody. Welcome to my talk. As I was introduced, I'm Clelia, and today we're going to talk about the anatomy of Lobster X. If you want to, you can follow along this presentation. You can open it on your device through this QR code. If you don't, it's fine. Everything's here. So a little bit about myself. As I was introduced, a member of technical staff. I mostly work in agent, retrieval system, open source. I have a background in computational biology and drifted in AI and engineering. I work mostly on agents, and as I said, and today I'm gonna give you a guided tour of one of these agents, which is called Lobster X. Since we like crustacean agents, like OpenClaw, we're keeping it crustacean team, so we're gonna have Lobster X. So, what is Lobster X? Lobster X is a document processing AI agent, which lives in a Telegram chat or wherever you want to deploy it, but it's mostly built for Telegram. The idea is that you send a PDF and a task, you send a document and a task. It parses the document, extracts it, classifies whatever you need, whatever is defined in the task, reasons, and replies. But it doesn't reply in the same way as you would, like, ChatGPT would. It is not a direct interaction. Like, it is not a synchronous interaction. This is a truly autonomous and asynchronous agent. That's what LobsterX is built for. And what is interesting in this thing, and what I'm partly proud of, is that this agent is contained is approximately 600 lines of Python code for the agent itself and 1.5K lines, 1,500 lines of the orchestration workflow itself, which comprises a lot of things that the agent itself doesn't use. So it's small enough, I would say, to be dissected. It's small enough so that we can have an anatomy of it. But it's real enough, and you can use it, you can deploy it on your own, and you can speak to it. It is real enough to be interesting. And that's why we're going to dissect an agent. Because, most agents like Cloud Code or Codex or other things might look like black boxes. You interact with them daily, but you don't really know what's going on like behind the scenes. Of course, for those agents that are open source, you can go and dig into the code, but code bases might be very big. You might get lost easily. So, most of us treat coding agents like prompt in, answer out, and obviously, we don't get to see the interesting engineering that's beyond that. That's like beyond the interaction, beyond the tool calling, beyond events and whatever. So what I'm going to do today is walk you through these 4 components that a little bit have to do with anatomy, deal with anatomy, which is the brain, which is the LLM that's behind the coding agent, the loop, I would say, which is the body, whatever orchestrate, like hormones and blood that goes through the body and orchestrate everything and gives all the commands and make sure that everything works. Eyes and limbs, whatever the agent uses to interact with the external environment, and ears and mouth, how it interacts with us, humans, in a human-readable, human-understandable way. Let's start with the brain. The brain is an LLM, as I said, but LLMs have one big problem. So they are essentially, and we use them as decision makers, but they are essentially non-deterministic. So the problem you have is that you cannot really get the same output from the same input, which is something that in agentic system, in reliable agentic system, we want to avoid as much as possible. We want to have determinism. We want to have something that we can measure, as I think also previous talk said. So what we want to do is we want to constrain the model's output into a predictable form that we can then use as downstream output for downstream input for other steps that our agent takes. So what we need to do is we need to make the brain reason clearly. If the signals of the brain are mixed, are undeterministic, are unpredictable, the body doesn't work. So what we need to do is we need to do structured outputs. We need to use structured outputs, typed JSON schemas that represent whatever we want. So they represent the reasoning, represents the action, the tool calling, represent observations and stop reasons and whatever. So the agent is constrained into that. There's no like raw chat. There's no possibility of the agent, like for the agent to escape that. And we can take those outputs and inputs, JSON outputs as inputs, and we know that the agent will have produced that. And if the agent failed to produce that, we use a validation framework, such as Pydantic, then tells us that the agent has failed. The agent fails loudly, and failures don't go undetected because of the inherent undeterminism of the agent. Also, it is kind of interesting because we can reuse the same schema across, like for example, for Pydantic, we can reuse the same schema across OpenAI, Anthropic, Google. So it is kind of a universal language that we can make our LLM speak. Our brain, so that our brain can be understood by other parts of our body. And the messages can be relied by whatever connects the brain to the moving parts. And this whatever is the loop. And we're using LlamaIndex agent workflows, or how we say it, like for short, Llama agents, which is an event-driven, async-first, stepwise execution engine. I would also add non-opinionated, because it's not only for AI. You could use it for everything that needs to be executed in steps. And it's basically each step is a typed function, strongly typed function. Of course, Python doesn't have types, doesn't have a strict typing, but with this, we try to enforce a strong typing between a strong schema and type between every step, so that we know that when an event comes in, it has a specific schema that the step can use, manipulate, and then emit another event and make the workflow go on. One other thing that is very important beyond this event-drivenness of the workflows is that the workflows are asynchronous by default. So we have async as a first-class citizen. The workflow executes asynchronously. It can be distributed. Can be run as a server. You can do whatever you can do whatever you want, and it basically allows you to build long-running tool calling events that basically don't block the workflow itself. And we do have a lot of other things: looping, branching, human in the loop, stateful executions, storage, as I was saying, multi-region distributions. We have a lot of things, but this agent uses a very simple, let's say, loop. The very simple loop is input, user input. The agent first thinks, produces a thought about the input, then acts. It can either call a tool or say, OK, I'm done, I'm finished. So it's acting, calling a tool. It then observes the result of the tool. And if it deems that the actions have been OK and everything's up to now is good, it just stops the execution. Whereas if it deems that the actions are incomplete, and generally that's what you want. Like after a first turn, after a first iteration, you want the LLM to be critical, self-critical. You want the agent to be self-critical and say, OK, there might be some things that are not the best, so let's go back. We go back to thinking, we act, we observe. All of these is controlled by event-driven, an event-driven architecture, as I was saying, and as I was saying, also structured outputs that let us know and that make us able to predict input and outputs of each step from the LLM and making it deterministic. Of course, the internal system of the body doesn't work in and on itself if it doesn't have windows on the outside, windows on the world. If it doesn't have a way to interact with the environment. And there are 3 windows of the world, as I was saying: file system, document tools, and chat interface, which is what makes this agent specifically a document agent. So let's start with the eyes. The eyes is a virtual file system. I don't know if you know them, pretty famous. Agentfs by Torso is the virtualized layer that works as a file system for us. We're not using the real machine file system. everything that has to do with the file system interacts with the virtual one and not with your real one. There's also the option of making interact with the real one, but you don't really want that, because you don't want destroying actions to be destroying and like dangerous action to be performed on your own file system. You don't want the agent nuking your own file system. Also, we exclude, by default, we exclude secrets files like .env or .npmrc or whatever. So credentials files, secrets file are excluded by default, which means that the agent can't read them. Even if it wants, it can't read them because they're not in the virtual file system. Of course, you can avoid that, but giving the agents your credentials in a .env files might not be the best idea. Of course, everything that goes through Telegram, all the documents that you upload through Telegram or through other interfaces are not written onto your disk, are written into agentfs, which is basically an SQLite-based file system that just virtual file system that just keeps the data there. So even if the agent is jailbroken into performing a dangerous, destructive action, what gets destructed is the virtual file system and not yours. Of course, when you're like, okay, and when you've verified that everything is good and there's no dangerous data that has been put into your virtual file system, you can sync and mount that virtual file system into your real one. But up to that point, everything is kept there. And it's onto you, the human, to decide whether data is safe enough to then sync it and port it to your own real file system. Of course, now it comes the, I would say, most interesting part. As I said, LlamaIndex is a document processing and leading OCR, agentic OCR platform. And we gave to Lobster X 3 tools that come from the LlamaParse platform, or LlamaCloud as it was previously known, which are LlamaParse, LlamaExtract, and LlamaClassify. So what do these tools allow you to do? So LlamaParse allows you to parse PDFs, Office documents, images that contain text into actual text that the machine can read, that the agent can read. Of course, you might say, yeah, but Claude Code can read PDFs. I would say, yes, that's true, but it uses presumably PDF to text or some other kind of like PDF converting tool that scrambles the whole layout, that like crams together tables, that ignores images. So you don't really want that. You want something that preserves your document as is. LlamaExtract, on the other side, is able to extract structured data from documents based on a specific JSON schema. And LlamaClassify can classify documents, unstructured documents. When I say unstructured documents, I mean PDFs, Office documents, images, anything that cannot be read directly by humans, by machines, as it is not written in like plain text, like Markdown or text files. So basically, LlamaClassify classifies documents into user-based categories. So these tools actually help us change the game, help us make an agent a document agent. Because, you know, you tell the agent, well, you have this directory of data, go through them, tell me what is going on. Some of this data are contracts, some of this data are invoices. So the agent, what does the agent do? The agent creates a schema for the contract and the invoice. The agent classifies each document as contract and invoice, parses each document, extracts the schema, and then comes back to you after, I don't know, an hour or so of work and tells you, okay, you have 50 inboxes, 60 contracts, here are the patterns, here are the things. That's what we want from a document agent. That's what we want, like autonomy of working on PDFs without you having to control the output, without you having to check that the agent has crumbled columns, the agent has messed up your layouts, the agent has misinterpreted the PDF's images. Whatever you need is basically in these 3 tools here, like parsing, classification, extraction, reliable are in these 3 tools here. And obviously, you know, this helps us make the agent better and help the agent improve itself. Because, you know, sometimes it might produce a wrong schema, sometimes it might not use it correctly. So we can then provide feedback to the agent, and the agent will eventually, over several iterations, come to a perfect like document workload for your specific use case, because obviously you can tailor this to your specific use case. As I said, we have ears and mouth. And as I was saying, this agent is asynchronous by default, so the obvious choice for this is a chat interface like Telegram. When you write to your friends on Telegram, you don't expect them to write to you immediately. That's what happens when you go and talk to ChatGPT. We don't want that kind of experience. We want the agent to be autonomous. We want the agent to be asynchronous. Thus, we deploy it as a Telegram bot. You interact with it as a Telegram bot. You upload files to Telegram and whatever you need. And then the agent can basically pull the files from the virtual file system and interact with them. And that's basically it. When the agent is done, pushes a notification. You get a notification on Telegram. Take a look at the work of the agent and go and interact again, start again. The agent has memory of previous interaction. So that's basically what helps it, as I was saying, what helps it improve over time. There's also the possibility of deploying these as a fast API server, if you want. There's some minimal stuff I put there, some auth, cores, rate limiting, and task management. But obviously, you can always tweak since the code is open, and this is all open source, you can just go and take the code and put it in your infra or whatever you want, tweak it, deploy it as you want. Just a very quick note on safety. As I was saying, the first thing that we did for safety, is virtualizing the file system. We don't have exposure on the OS file system, so you can deploy these also on your root. I wouldn't advise it, because there's a ton of files probably in your file system. This goes through all the files recursively, so it's going to have a ton of files. But you can deploy it also on the root of your file system. And this won't corrupt your real machine file system. This will only corrupt the virtual file system if there is corruption. We don't have shell execution. The agent cannot run arbitrary bash. Read, write, and edit only tools. We don't have deletion tools for files. This might be a little controversial, but at the time, skills was a little bit early. So I was no skills. Let's just use agents.md. Agents.md is controlled by you. Skills are controlled by someone else, and you download them. They are potentially unvetted. There might be prompt injections or other safety concerns. So that's a thing you have to keep in mind when you use skills. So that's why agents.md and credentials files are excluded, as I said. Obviously, this doesn't mean the agent is 100% secure, but most of the things that the agent can do wrong are done, are taken care of. This is the full anatomy. We went through brain, limbs, eyes, ears, and mouth. And there are a few takeaways that I would like to leave you with my last 50 seconds. Structured outputs are the most important thing that you can do to make your LLM deterministic and predictable. Layout-aware document tools, are the thing that makes you able to, makes your agent able to really understand documents and unlock real understanding of documents. And then obviously we have event-driven workflows, virtual file system, and async interfaces that you can all use to make your agent better, to make your agent infrastructure more reliable and more controlled, more observable, and your user experience, I would say, more synchronous and more feels like an autonomous agent, feels like AGI. You can find all the links, GitHub, blog post, workflows, whatever, in the presentation. I put the QR code at the beginning. Thanks very much.